Moving to the second problem, okay, when dielectric is partially filled between the plates. As I have mentioned earlier, we have seen that if dielectric is completely filled, then we have understood about that electric field is reduced. What if the dielectric is filled only some thickness which is less than the separation between the plates? Okay, so therefore if a dielectric slab of thickness T, the T is less than, so this is T and this is D, so T is less than D, is inserted between the plates as shown, the new capacitance. So now the capacitance is going to vary. If it is filled full, then C prime is kappa times C simply. But now the thickness is there, then the term T also will be included in it. And how are we going to find out? So the expression is derived likewise. The potential difference between the two plates of capacitor is given by V prime, which is also, we know that V prime is nothing but, according to potential gradient, V is equal to ED. Okay, therefore this is the air space and this is the dielectric space. So what is the air space when you place the dielectric of thickness T? The leftover space is D minus T. So instead of D we will write E into D minus T. This is for air. And for the dielectric, you have the electric field here is going to be E prime T. Okay, because overall the original field and the induced field, then the resultant field will be in this direction is reduced field, as reduced field is denoted by E prime. So we have here E prime into T. Okay, as we know that from the previous formula that this kappa can be written as original field by reduced field, then reduced field can be written as original field by kappa. So in place of T prime we have written original field by kappa into T. Then E is common here. Taking it common, you will have D minus T plus T by kappa. Okay, then what I am going to do, since the electric field from the plate, so plates have the electric field sigma by epsilon naught, as the term is as it is, and sigma can be written as Q by A epsilon naught D minus T plus T by kappa. Okay, so these are the formulas I have used here. Okay, then now capacitance, that is we are going to determine new capacitance. New capacitance is C prime. C prime is written by Q by V prime. So what we need to write it? Q by V prime. Therefore Q divided by, what is V prime? Q by epsilon naught A D minus T plus T by kappa. Q gets cancelled. This 1 by epsilon naught will get reciprocated. Therefore you get epsilon naught A by D minus T plus T by kappa. Okay, a very important formula both in CBSE as well as in many competitive examinations. So need to practice this, and the thickness really matter. Now what will happen in the models of question, that you need to realize it. This thickness, okay, if I start placing more than one dielectric of different thicknesses, so that is the case here. Here you see it, these are the plates, and in between I have placed different thickness, okay, of T1 and kappa 1, T2, kappa 2, T3, kappa 3. Then what I am going to do, in place of T I will write T1 plus T2 plus T3, so on, how many are there, and in place of this I will write T1 by kappa 1 plus T2 by kappa 2, so on. So this is the expression which is getting modified. Okay, if I start filling up the entire space between them with 4 dielectrics here, okay, then immediately you will see that this T1 plus T2 plus T3 plus T4, it's equal to D, isn't it? So therefore this term D and T will get cancelled, henceforth only this expression will be there. That's why epsilon naught A by T1 by kappa 1 plus T2 by kappa 2 plus T3 by kappa 3 plus T4 by kappa 4 is left in the denominator. These are the two important models of question in this category of problems. Okay, work it out. Instead of dielectric, if they place a metal slab, okay, so a metal conductor, remember a metal conductor has the dielectric constant of value infinity. Okay, so if they place it in place of kappa, you place infinity, 1 by kappa will become 0. If the metal slab is completely filled, then capacitor is short circuited. It means that this is a plate, this is a plate. Okay, in between these two plates I have placed one conductor, so it gets short circuited. Okay, so therefore what happens when it is short circuited? How will you write it? C prime equal to kappa epsilon naught A by D is generally we write it. So kappa for metal is infinity, so therefore when it is completely filled with metal conductor, the capacitance becomes infinity.